farm just south of Sunburst, about 4,000 dry land acres of farm. So very contrasting to what you just listened to there. And we averaged 10 to 12 inches of rain over the last 20 years. Since 2016, we've averaged about 6 to 7 inches of rain. But we've been able to do some pretty amazing things just by cutting out a lot of the inputs that I actually used to sell. So little background, I was an egg retailer and an agronomist too for about 25 years of my life. We just quit egg retailing about 2 years ago because I couldn't sell people paraquat on bare ground anymore. And it was more of a ethical thing than anything to me, I think. But long story short, there's our rainfall since about 2016. You can see it's been pretty low, but we've been able to keep kind of pulling decent crops off of this with not many inputs. But what really got us going in the soil health direction is during COVID, my sister had to come back to the farm so her kids could go to school there because the school had closed where she was at in Spokane, Washington. She helped us get way into the soil food web stuff that Dr. Elaine Ingram, or any of you guys familiar with that probably. So the bacteria is a big part of this, right? But getting this entire web functioning, whether it's the earthworms in the soil or the protozoa and the fungal part, those are the parts that we really screwed up when we were selling all these egg inputs before. And so I'm going to kind of get into how we screwed it up, and then how we're trying to fix it, and then how we're trying to use these guys as product to kind of bridge some nitrogen and phosphorus gaps specifically for what we're doing. So the first thing we did when we came out and we homesteaded this stuff, we started tilling the soil. And as you heard in that first presentation, any sort of tillage we do is very destructive to the fungal network, right? And so if you guys go out and you do any soil health tests, like those PLFA tests she was talking about, there's basically no fungus, or not, there's no fungal count in any of these soils anymore because we've destroyed it with stuff like 5 passes of fungicide or things like seed treat, right? So the first thing we did is we tilled it. That kind of screwed our fungal network up. But because we broke this soil food web, then we started to have to add all these inputs that I was selling people. We started anhydrosing, added insecticides because we had unhealthy plants that were getting attacked by insects. We add seed treat to the seed when we're seeding it, right? And when you start compounding all of these things, what I'm trying to show here is none of this stuff happens in a vacuum. So every one of these inputs that we're adding is affecting something in that soil food web, and most of it in a negative way. And this doesn't mean that we're organic. We just need to be cognizant of the fact that if we keep treating our seed and we're putting biology down, or we're trying to put fungal heavy stuff down with fungicide on a seed treat, how good is that going to work, right? That stuff, they spent years designing fungicides to kill the fungus that we're trying to get going in the soil. So what we have done, this was my last slide. These slides are a little different than what I had in my presentation, but what made us stop this finally, so my little bird's the only thing left alive here, right? What happens up around Sunburst, because we're in such a dry area, is there's a lot of fallow there. And so we got to the point we couldn't kill a lot of the weeds with glyphosate and fallow anymore. When we got to the point that we couldn't kill stuff with glyphosate, our only option was paraquat for a lot of that at that point. So around there on the fallow end, there is 3 passes a year of paraquat going on bare ground on fallow ground, which makes 0 sense from a soil health standpoint. And so we've gone a whole different direction on our farm. And what we tried to do is eliminate things first that were getting in the way. So right away, we eliminated seed treat. A lot of you guys are probably familiar with that Inspire seed treat that EarthSmart sells. We got a lot of that goes on down there. What happened when I was retailing is we put a lot of Inspire out on seed. And when we did that, we kept waiting for a wreck to happen because we quit all the fungicides, right? And the scariest thing to do is to quit treating seed because there's no fixing that. Well, we did it on our place, and there was a couple other guys. Most of the guys that came with us have been very progressive in this. We all did that and had 0 issues with disease. And so then you start thinking, if we put supportive stuff on this seed instead of putting fungicide on there, maybe we can do similar things with the rest of the farm. So we eliminated seed treat, fungicide, insecticides. We don't put any fertilizer through the drill anymore. If you're in an area like we're in, where we're only cutting 30 to 40 bushel wheat, even on a good year, we're only pulling 30 to 40 pounds of, not even that, probably 20 to 30 pounds of phosphorus out of the ground, right? And so there's a lot of stored phosphorus. If you do a total nutrient analysis, it's just tied up in the ground, which I'll get into here. So what we did is we started with doing compost in Johnson Sue's, and we would extract that and apply that through the drill to basically reseed all of this soil food web back with the drill as we were doing it. And we've been actually very successful on getting our fungal numbers to come up in the soil. We're starting to get protozoa back in there. We can find earthworms again, which anytime you guys treat seed with neonics, which would be in our country macho and gaucho, I don't know what you call it here. You've got cruiser on canola or something, right? Those are all very hard on that part of the soil food web. So, and they hang around for a long time in the soil. So when we got away from that, it took a couple years, but those things started coming back. But we still wanted to speed this up a little bit because we wanted to start cutting a lot more fertilizer out of this too. So what we did first off was apply all this biology, which you can do just by composting basically. We extract that out and we inoculate the ground basically with all this different biology. We can verify that under a microscope so we know we're getting all this biology down through the drill. And so that was working okay, but what would happen in our transition years is we had a deficiency in nitrogen and phosphorus on some fields and not others, but we were getting yield dings because our soil wasn't cycling correctly. And so that's kind of what brought us to these guys, because they've been very focused on function-focused biology or whatever, that'd be very good at solubilizing phosphorus or pulling nitrogen out of the air. And I'll get to kind of how that's worked then as we go forward. So now we've got all parts of our farm working together. We've integrated livestock in most of the farm ground too, which they're awesome for inoculating the ground because every cow pie has all of the soil food web in it, as long as you don't pour the cows, right? So so what we did initially then is we eliminated starter fertilizer. I'll get into how that's been working. It's actually going in a surprising direction. Our phosphorus numbers are going up, not down. We don't have spray for oats. Mostly that's crop rotation and low disturbance drill that we're using anymore. No more fall spray. That's only selective where we have Canadian thistle. And maybe a cheatgrass issue, which you don't have unless your rotation gets out of whack. But no seed treat, no fallow. We quit fallow about 10 years ago now, I think, which you guys have done up here forever. You're always like 10 years ahead of us on everything up here as far as farming practices. But no lease ground on that fallow. So the other thing that was happening there is we were paying leases or land payments on ground that was sitting bare. And then at the same time, what used to happen when we did more recropping before our rotation was diverse and we got out of the way of some of the biology is we would have to add a bunch more fertilizer when we switched from fallow to recrop. Now it's going the other way around, which is pretty exciting. So in our low input farming system, we were able to cut about $160 an acre of inputs out that we were putting into just getting one crop in a fallow system, basically. So the next question is, my classic agronomy brain, none of this makes any sense, but aren't we mining the soil? And certainly we are always mining the soil for something, right? But my thought was, so this is the first test you can see, which I can't really point at this, but the left side, that's showing nitrate. We don't really care about the nitrate on this sample, but the phosphorus parts at 18 parts per million in that sample. On the right side, this is now the fourth year where we put no starter through the drill with no phosphate and pulled 4 crops off of there. Using those guys as product, which this is actually relatively impressive to me, we actually took the phosphate level from 18 parts per million up to about 50 parts per million on that soil test without applying any starter, which is mind-blowing, right? If you ever do a total nutrient test, if you guys send those off, you're going to see there's a lot of phosphorus just in the top 6 inches of the soil that's just tied up. And if you can start accessing more of that profile, like if we get below 6 inches, all of that can start to multiply as far as the amount of phosphorus we can access. So long story short, we'll keep going this route until we see a problem. But what's happened as we switch directions here, so 2018 was when we were still doing the full program I was selling everybody. We were spending about $350,000 just on those inputs. And then when we got it all the way down to about 150,000 or a little below 200,000 anyways. But what happened when we dropped it that much is we were having some nitrogen cycling issues. So we added a little bit of biologicals back in there, which is these guys' product. And we're seeing now a lot of results that are very promising as far as tissue tests without nutrient deficiencies. So just real quick, your source of seed is pretty important because there's things called endophytes. It turns out that bacteria and fungus can actually live within the plant too, and it moves around, right? Keeping your own seed when you reseed good regenerative seed actually already has some of that biology in it. And on top of that, in theory, these guys' biology would be retained in that seed when you reseeded it to some extent too, right? And so the science on this is advancing so quickly, that there's all this cool stuff. They found out roots can eat bacteria, which John could get way deeper into this than me probably, but there's something called rhizophagy, and they can take the bacteria in, strip nutrients out of them, and kick them back out of the plant. And so there's some really neat things that they're finding with nutrient transfer between bacteria and the plant that we didn't even know was possible just a couple of years ago. So we applied biology back to the soil. We built Johnson Sioux bioreactors. We extracted those. This is just that extractor running. That's just bubbling and peeling the biology off of that compost. And then we keep the heavy stuff in the middle and then put the rest out into the field, basically. And I know I'm running out of time, so I'll go fast here. But so that compost extract had the full soil food web in it, which was really cool. There's products like Pivot Bio and Nutrish. Those are all bacterial products with just one strain of bacteria in it. The compost extract, in theory, has everything in it. But what we weren't getting was a big enough flush of the bacteria that were beneficial for things like phosphorus solubilizing stuff. And so that's where their product fit. So inspecting the extract, we do that all under the microscope. It's pretty easy to learn how to run that. But what's cool is you can see their product under the microscope too. And when you start brewing it, the bacteria may not be very thick under there, but when you finish, you can tell how much you've amped that up. And that's one of the things that makes these guys very unique compared to buying bugs in a jug, is that you're buying stabilized bugs, you're doing a compost tea basically, and ramping that stuff up, and your bacterial counts are so much higher than anything you could get in a jug. That's one of the things that drew us to them, is that it's a very unique situation as far as their process too. So they went through all of this. I'll skip that slide, but what I really like about these guys is they're very research driven, as you can see. It's a family run business. It's so very different than when I was in egg retail dealing with Syngenta or Bayer, because it's not focused on the Midwest, or it's not focused on how do we sell this to make the most money. They're doing it in a very intellectual way and with a lot of integrity, I think. And so I think these guys have done a fantastic job. That John has dedicated his life to figuring this out, which is great. And then the Day Chief family, starting with Phyllis, who had this crazy idea, which sparked all this, which I'm sure you can watch a video on all that. They just have a really cool story, and I think this product really fits for what we're doing pretty well anyways. So how are we verifying this? We do PLFA tests, which are fungal and bacterial kind of genetic marker tests, which she talked about at the beginning. This Blue Dasher Farms is coming out doing a bunch of genetic sequencing on the biology, which we'll get pretty soon, and insect counts and water infiltration. And we've got neighbors all doing similar things to ours, which is really cool. And we'll get those tests back from that Blue Dasher Farms to see which thing will work the best. So, like I said, we've been able to take our fungal bacterial counts up to above average compared to where there was none in the soil before. So this is a test after we did some of this stuff. And then this is tissue tests from this year. So we actually had a pretty good start to the crop with no applied starter fertilizer, no nitrogen. A lot of this is barley on barley, which normally would be a bit of a wreck if you didn't apply nitrogen to start with. All of those tissue tests were sufficient in nitrogen and actually slightly above. So that's encouraging how things are cycling. On the phosphorus end, even though our soil tests show high, we wanted to verify, of course, that we were getting at least phosphorus up into those first 4 or 5 leaves of that plant. All of the phosphorus was sufficient at that point with no starter fertilizer. And then when we got later into the summer, we hit some pretty good drought stress when those guys were out there for our field day. We still had pretty much sufficient nitrogen, which you might expect at that point because those plants weren't pushing very hard there. But that's still encouraging to get that late into that with no applied fertilizer. And the same thing on the phosphorus, we were able to maintain that into the flag leaf, and it was still completely sufficient on lots of different fields. So the whole point of this is we're just very careful about testing because this is a major direction shift that we've gone in. We've saved a whole bunch of money over about a 5-year period here because we've hit droughts, right? On top of the fact that we cut fertilizer. What we need is for a wet year to see if the wheels come off of what we're trying to do here or not. I suspect now we're enough years into this that won't happen, I think. But there is way different ways to go about this compared to how I used to sell people inputs. I can tell you that anyways, I think. So we get lots of, so that's a rhizosheath basically on your plant, right? And in there is where all of those root exudates have gone back and forth with bacteria and fungus, and they glom on dirt on your roots. But long story short, if you dig plants up and there's all that soil glommed on the roots, that's a pretty good sign that you have a healthy rhizosphere in there. If you have bare roots, like used to happen when we treated the seed and put a bunch of urea down through the drill, then that's not a good sign.